Hey everyone, can you hear me? Cool. So thanks for coming out. I understand there was some reluctance to leave tea earlier, but yeah, it's good to have you guys here. So I'm Azhar, this is Nick. So we work at a company called Thinks. It's an applied research firm based in South Africa. We're the guys that build Canary, so it's an alerting honeypot that runs on pretty much many data centers across the world. And we spent all of our time thinking about how to make detection of attackers snooping around sort of painless and effortless. And this talk comes out of that sort of thinking. So we pursuing that sort of line by using detection, using an alternative to honeypots called honey tokens or just tokens. And that's what we were talking about today. So we have three aims in talking here today. We'd like to introduce the idea of tokens, and then we'll talk about the infrastructure that we've built to revive tokens and take it in a few new directions. And for most of the talk, we're going to deploy and apply these tokens in different settings to see how we can detect internal threats. So to kick us off, let's just know the recent fact from a recent data breach. So 2 weeks ago, a hotel chain publicly announced that earlier this year, their point-of-sale system were breached and credit card details from people who had stayed at their hotels or visited their restaurants were stolen. And there was a period of 5 months or 142 days in which the data was being stolen. But already a month before that announcement, Brian Krebs had reached out to the chain suspecting that a breach had occurred. So he had heard from sources in the financial industry about a series of incidents that suggested that there was some sort of widespread compromise at this chain. And from the timeline, it appears that Krebs learned on this just shortly after the hotel chain learns of it. I mean, this is a little bit better because there'll be those cases where Krebs finds out the breach before anyone inside an organization learns of it, and not at the same time. So now I don't mention this breach to pick on this hotel chain. I mean, they're in fact quite a typical case. So their breach time is almost exactly the median time reported to detect breaches as according to a recent Mandiant report. So their report surveyed a number of breaches they responded to in 2015 across different industries, and half of those breaches examined for those reports still took longer than 146 days to detect. And those are sizable time periods in which attackers get to play, but it's also a lengthy time in which they can tip off defenders. And that's the focus of this talk here. So our focus is in detecting threats, say, on internal networks during that sort of time period of an undetected breach. And this is in contrast to some early honeypot research, or even some today, where there's an attempt to sort of track and learn and study attacker behavior. So our colleagues, Marco and Arun, gave a talk about that recently in a talk last year at Black Hat, where they went in more detail about that, so we won't go there now. Here, what we're more interested in is we'd like to know, has someone broken in and been someone they shouldn't be, like exploring a critical database in production or amongst documents in an important file share. And it's in this setting that the defender has a particular advantage. So once attackers learned inside your internal network, they're at a disadvantage. They don't know the lay of the land, and they need to explore it while remaining hidden. So the defender, on the other hand, has a good idea of how things are laid out. They know where the valuable things are. And to make use of this, one way to make use of this advantage is for the defender to make the territory inhospitable to attackers, outsiders, and strangers. So places where attackers are likely to poke around and where your regular users don't go are good places to lay traps or tokens that trip up attackers and alert you to their presence. So this idea of laying traps or honey tokens to trip up adversaries is an old one. So related ideas will come up under different names. So for example, map makers had this idea of trap streets, where they'd insert a fake city or fake town or fake street on a map. And if someone ever copied their map instead of doing their own hard work, the trap street would give the game away. And in computing, people have explored setting tripwires and files and spreading honey tokens or just tokens to try and detect people snooping around. So earlier tokens tended to be a bit more passive. So to give an example of that, a really old example of a honey token is from 1987. So it was documented by a guy called Clifford Starr in his book, The Cuckoo's Egg. So he had discovered that there was a hacker that had broken into a computer lab where he was the sysadmin. And from watching the activity, Cliff Starr could see that the hacker was interested in military affairs. And he would also go through emails looking for useful information. So later it was actually discovered that the hacker was selling information that ended up being sold to the Soviet Union. But as a trap to find out who the hacker was, Starr manufactured fake emails and left them lying around, knowing that the hacker was interested in this stuff and would go with him, because he also made the emails look sort of very bureaucratic and military in a way to appeal to this guy. And one of the fake emails encouraged the reader to send their address, their postal address, to one of the secretaries so she could send sensitive documents back. And there was a hope there that the hacker would get this and would actually send something and send the actual address that revealed something about who they were. And quite amazingly, this actually worked. So the guy got there, took the postal address, sent it along to some intermediaries, who eventually sent an email, sent a post to it asking very politely for some documents later on. So a more modern version of this would work similarly. So instead of a postal address, you'll leave a link with credentials in an email. And if someone's snooping through the email, they see this link and they see some credentials. It's very tempting to just check it out, see what more you can get from it. And on the defender side, if you see anyone using those credentials, either on a fake site that you set up and run, or on a legitimate site where you're monitoring for those credentials, it's good cause to go investigate. However, I mentioned that these things are a little bit passive, so there's still some work that the defender has to do in running that fake site or monitoring for those logins. Another example of a token that's quite passive is fake data in a database. So by planting data that looks valuable to attacker, they'd be likely to take it and attempt to take it elsewhere. So credit card data is one example. This could have perhaps appealed to the attackers in the breach I mentioned earlier. And the difficulty with this setup is that it's really quite passive, so the defender needs to actively monitor for its use. So in some suggestions they set up monitoring like this. You'd have the attacker accessing the database via some sort of router, which happens to be a network choke point where you can watch traffic. And if the attacker managed to gain access to the database, pulls those token data out, and when you're monitoring, you pick up the fact that the token data is leaving your network, you can eventually send an alert. So an alternative, which isn't much better, is you could monitor shady forums to see if the data pops up. With something like credit card data, this could work, but it's still quite a lot of work for an attacker. But I've been mocking older tokens a bit back from the early 2000s, late 90s, or even late 80s. But not all of the tokens were that bad. So this one example was quite interesting that we just learned about quite recently. So 2 months ago, some documents were published on Operation Moonlight Maze. And this was an investigation in 1998 by some US agencies into widespread intrusions across university and military networks. So the incident was quite well known at the time, but the details were kept secret. So a researcher sent in a Freedom of Information request to get more details about the incident. And what was very curious is that already back then in 1998, the investigators used a honey token document. So a document that they left lying around that when stolen, the guys who got the document opened it up, and the document made a DNS request that alerted the investigators. So we'll touch on this again later in talk, but it just for us was quite interesting just because we hadn't realized quite how early on that technique of using DNS to alert you that some open document had been used before. So without really looking at tokens in this talk, what we'd like to do is aim at detecting attackers snooping around, but without using honeypots, without setting up network monitoring at choke points, and without using endpoint agents on workstation and server. So honeypots will get a brief mention towards the end, but it really isn't actually necessary to talk about tokens. So the aim here is to use the defender's home ground advantage to alert on significant events by placing tokens that are actively in the way of some attackers snooping around.
In order to achieve this aim, we built Canary Tokens, which is just our take on tokens, with new ideas and full implementation. Our goal has been to make it easy for anyone to quickly generate new tokens and scatter them around your network, leaving them there only to alert you if ever triggered. Importantly, we are creating tokens that look valuable. The point is to trip the tokens up and alert you of their presence. So we bring in the old passive tokens into 2016. We're going to be emphasizing this point throughout the talk. We've built tokens to make it easy for you to use them. So Canary tokens are a basic idea. You embed a unique identifier into the thing you want to token. When the token is triggered, you'll get an alert telling you that someone is somewhere they shouldn't be. The beauty is that these basic ideas are composable, meaning we can combine them in different ways to alert you in different settings. So let's take a look at some of the simple channels offered by Canary tokens. Perhaps the simplest token is a URL. When it hits, we'll get an alert. It's a simple action, but it's going to be powerful, as we're going to see. Coming back to the example as mentioned earlier about leaving a URL in our mailbox, we can now create a token URL and leave it there. If it ever gets hit, we know someone is snooping around. So let's quickly demonstrate this basic canary token. What we're going to do is we're going to be going to our canary token server, we're going to provide a few details, and then we're going to generate a unique token. You need a supply email address. This is where the alert will get sent to. You'll give a description for your token, so you know exactly which token is going to be getting hit when you get the alert, and then you generate. Once you've generated, you'll be given a list of available tokens. We're going to be focusing on web bugs for now. So if you click on web bugs, it opens it, and you'll be given your unique URL. So this is now your unique token URL that if an attacker ever gets hold of and tries to navigate to, will trigger an alert. So the attacker now navigates to it, and he sees this page with a quote there. In the background, what's happened is it's hit our token server, which has returned in this response, but has also alerted us of our token being tripped. We'll now get an email saying someone's tripped over our token. We can now take action against it. So,
Actually, you just want to give us 2 seconds. We've just logged out of our email where we'll be getting the alerts from.
So importantly, you need email to be able to actually get the email when that happens. We've also added, you can also get notifications of SMS, and we've recently added webhooks. So you've got 3 different channels to get notifications over.
So you just give us 2 seconds. I don't want to show you my password manager while I get the password out.
So thank you. Thank you for pointing that out. So you're going to make our point even better. It's coming. So he just said that the URL there was canarytokens.org, and that's going to give it away. We'll explain exactly what happens there, which I can do while this is happening. So Canary Tokens is open source. You can download it yourself. You can play around with it. You can run your own servers. We've even got Docker files, so you can download Docker files, get your own servers running up with your own domain names. So that's the beauty of it. You can run your own servers easily with a few Docker commands. They'll be up and running, and you can create tokens. You can create multiple domains. You can do whatever you want.
Okay, we're almost ready. And we'll just get you guys back in so you can see the alert has actually come through while we were fiddling. And are we seeing that? So yes, that's just basically the simple alert that Nick was chatting about. So Nick, over to you again.
So from that alert, we saw that our basic HTTP token was triggered, and now we can take action. So it's important to note that now this is our basic token. We're going to be using it in other tokens to create more sophisticated tokens. But it's important to understand the idea of what just happened. We created a basic URL. If that URL is ever hit, it hits our token server, which returns a response, but importantly, alerts us that someone's trying to hit our URL. So now let's look at some other channels supported by Canary tokens. Using DNS, we can alert when a host name is looked up. So here the token is the host name. When it gets resolved, it'll trigger an alert. So we can quickly see how that works. Following the same steps as earlier, those 3 simple basic steps, you go to your token server, provide your email address, give a brief description of what the token is going to be used for. In this case, it'll be something to do with our web bug demo, so we know our DNS demo, so we know exactly what it's for, and generate the token. You'll then go down to your DNS token, and you'll see your DNS token, your unique DNS token there. So in order to mimic an attacker hitting this, we'll just host it. So what's happening in the background is that domain's getting resolved. It's hitting your token server, which is returning the response, but at the same time creating the alerts, letting you know that someone is resolving your DNS token. Once again, this is another simple building block that we're going to be using to create more sophisticated tokens. So now we have HTTP and DNS. So DNS is useful, it doesn't need a direct connection, and there are lots of places where DNS query can get out, but your HTTP would fail. It's important to note, though, that DNS does mean you lose the IP address, whereas HTTP gives you the IP, but loses out on restricted networks. The next channel we're looking at is SMTP. Simply put, we're modernizing the old idea of the fake postal address mentioned earlier. The key here is that the token is the email address, and the alert happens when an email gets sent to it. So once again, we can just quickly show you exactly how to generate it. Basically, we're just showing you that these are so easy to generate. In a few steps, you've got whatever token you want. You can put it wherever you want. Provide an email, give a brief description, generate the token, and there's your SMTP token with a unique email address. So at this stage, you can do whatever you want with that email address. You can put it in a database of users. If it ever gets hit, you know someone's snooping through your database. So now we've looked at 3 basic channels that form the core of Canary tokens. These channels are used to build more powerful tokens. We've also built more specific token channels that have direct use cases. We can set up a Canary token server to poll services and watch for changes, alerting if there's ever an unexpected difference. So it's worth remembering what we want here. We're trying to find a simple way to get a heads up that someone's been compromised. So to demonstrate one of the polling tokens, we can look at a Bitcoin token. So let's set that scenario. You have a server and you want to know if it ever gets owned. You know that when an attacker breaks in, they're going to be looking for anything useful and anything they can monetize. So you leave Bitcoin wallets, or many of them, lying around the server. If it's ever emptied, you know the server has been taken. Tokens let you now monitor the wallet and alert you of the changes. Just going to point out, this isn't blockchain tech. We are just playing on the old trick of leaving money around to see if it gets stolen. So the way it works is, you give us a Bitcoin address, we save that value. We then poll the address for any changes. If the balance ever drops, we're going to send you an alert. So we've now demonstrated how you can use tokens to poll on a service and alert on changes. Of course, you could be saying you could easily do this yourself with a bash script, and you'd be right. What we're saying is, use tokens, we do all the hard work for you. Use appliances with an address, and the rest is taken care of. No monitoring, no management. It's all about ease and simplicity. So now we've looked at the fundamental channels provided by Canary tokens. When these channels are hit, you get notified of SMS, email, or our webhooks, as we mentioned. You may also have noted that our channels rely on DNS, and one different attacker could just block our traffic to our Canary token sites, as you mentioned. So we've got a few points on that. Firstly, people are using our hosted token server every day. We've got thousands of tokens that are currently in use from our actual server, our own hosted server. Secondly, as I mentioned, it's all open source. We have Docker images. Download them, play, send comments. We're always there and ready to make improvements. And finally, if you use our commercial honeypot, we're even bringing Canary tokens to your console. So it's going to be directly tied to your console. You have your own token server. This brings us back to the point we're trying to make. Canary tokens are simple. They're easy to use. There's no maintenance. There's no monitoring. You simply generate the tokens, scatter them around your network, you leave them. If someone trips over them, now you know. We are removing any reason for you not to be using them.
So Nick has covered the overview of the basic tokens we can create and how we generate alerts. So now, I hope you're on board yet, because this is where it starts to get interesting. So what we can do now with these basic tokens is that we can build on top of them and deploy tokens in different settings and generate alerts on more significant events. So what we'd like to do is use the tokens to trip up an attacker snooping around during, say, a breach that hasn't been noticed yet. And just as an aside, while this is intended to sort of increase invisibility, it's not a replacement for well-managed logging, which is very useful in its own right. However, one strength of tokens, which we'll try to show, comes from it being able to alert in some places where it's a bit more difficult to do logging in a more sort of traditional way. So our approach here is to consider significant actions that we'd like to notice that would immediately warrant some investigation. So for example, if there's a database in production and someone is exploring it, it'd be worth investigating. And then for any of these actions that we want to alert on, we'd find ways to embed tokens in a way such that the action will directly trigger it, rather than in, say, the passive token case where it's stolen and we monitor somewhere else and we set up something to alert on it. Now certainly, agent-based solutions could work for many of these, but with Canary tokens, we're exploring lightweight alternatives that are less intensive to deploy. So to start off with, there are times when process execution is a significant action worth flagging. So for example, on a very quiet server. So when an attacker first gains access to a Windows machine, it wouldn't be surprising if she first executed ifconfig or net.exe. So typically, it could be an extensive step just to sort of orientate itself on what network or whatever she's compromised. This is a clever idea stolen from Zane Lackey's talk on attack-driven defense, which is very well worth watching, by the way. And on a quiet, a stable server, if we got alerted to some sort of process execution, this could signal potential misuse. And we could track this with fully fledged logging, but there's a more lightweight solution. So Windows executables can be signed and have that signature verified when it's run, and we can rely on that signature verification to alert us when the executable is run. So I'm sure some of you may have guessed where this is going, but when the verification happens, a URL on the certificate is hit to fetch more information about the CA, and by replacing this with a token URL, we can get an alert when an attacker runs our binary. So as an aside, this also works, the exact same trick works for signed Office documents, but only when the Office document is not opened in protected view. So to get this to work, we just need to enable certificate checking on our executables, and we don't need any trusted CA for this to work, so certainly our fake one will do the trick. So let's show a demo of how this works. So we begin with the regular version of ipconfig that comes with Windows, upload it up to Canary tokens. Canary tokens will handle all that generating the fake CA with token URL, signing it and sending it back to us, and then we'll install it. So we create the token in the regular way with some sort of, again, some sort of memo that'll tell us what's happening. And when we scroll down, there's a section for uploading, signing EXEs or DLLs. And that's just a vanilla copy of ipconfig. We upload it, and in the background, the Canary tokens is taking care of generating the CA with token URL, signing it, and sending it back to us. So now the defender has to just install ipconfig, put it in place, and that's it. You can just leave it there. So if at some point later someone else lands onto the box, Nick breaks into this box, and he just decides to run ipconfig just to check out what's up on this box, he'll run it, the command will execute as usual, and you won't find anything too interesting here, but in the background, the verification has been run, and an alert has actually been triggered in the background, that alert that just came through. And that will have told us that since this is a quiet machine that we leave lying around that no one actually does anything with, it will show us that someone has issued ipconfig, and if I'm the only admin and I see that email, well then I know something's up. So by tokening signature verification process, we can use that. We can sort of ride on that to get an alert when the program is run. So early tripwires also monitored trap files that are looking for trap files or trap directories that have been read or browsed. So this is another thing that people could be looking for. And this is useful for detecting when someone is going through files looking for valuable data to take. And it's a good signal because there are a few good reasons to browse fake directory trees. And if you're looking for loot, you have to go through them in order to find good stuff. So we'll go through just a basic technique on three main OSs. So on Linux, basically, we've written a small daemon that you can use. It just uses inotify to get alerted on file reads, and that triggers a token to report back. So it's fairly straightforward. On OS X, it's even simpler. You can do away with the daemon. You can just use dtrace. It's an amazing system tracing framework. It runs on OS X. And it's very quick to set up a dtrace probe that detects when a file is read and automatically triggers the token for you. On Windows, it's a little bit weirder. We can actually use the desktop.ini to specify an icon for a folder. And the icon is a remote UNC path. And we can set that path just to include the DNS canary token, so that when Explorer browses the folder, it tries to fetch out the icon and triggers the DNS lookup. The URL looks something like that. So you notice there's something cool about it is that you can also report the username and user domain of the person browsing in Explorer. That's quite handy. And then, as an aside, you can also just package up this INI file in a zip or RAR archive to tell you when someone has opened and extracted that archive. So let's take a quick look at what that looks like. So pretending that Nick here is the attacker, he'll shortly switch to a machine that we've already set up a network share on, and he's gonna come across it, browse for it, and he's gonna trip an alert without knowing. So he's just come across the machine. He's taking a look and sees that there's two network shares. Data center one looks interesting, so he's browsing to see if there's anything useful. Maybe he needs to check out something about the network. Takes a look, doesn't see anything too interesting, and carries on looking around. So at this point, it's already a bit late as the alert has already been triggered. So one of those folders that he's in has already tripped that alert that you see there in the corner. So now we know that someone, Nick in this case, has been browsing our design documents on our data share documents. So those three techniques that I mentioned, the monitoring file reads and the directory browsings. So there's just ways in which you can leave fake directory trees lying around, and if someone starts snooping through them looking for stuff to take out, you can get an alert in the process. So I mentioned that really old Operation Moonlight would use the token document. So we'll just briefly touch on that here. And it's useful in the case where you're scattering token document across your real documents, or alternatively, if you're not monitoring file reads or directory browsing, it can be useful just to know if a document is stolen, open up a bit later. So on Word, there's not too much changes. Standard web bulk will work. On Adobe Reader PDF, it isn't that straightforward. So you can embed a URL which Adobe Reader will fetch, and you'll get prompted whether to allow the connection. which kind of defeats the purpose. However, there's an interesting way around it. So Adobe Reader pre-flights the certain DNS request for the URL, but that's only if the DNS is configured in a certain way, and we can use that to get the alert out. But net result is that it really doesn't matter that Adobe Reader prompts you for it, because if you use the Canary tokens one, the DNS is set up correctly, so you can just simply download a PDF and you get an alert when it's opened in Adobe Reader. So those two techniques are just how a way which you can easily generate token documents by just generating token Canary tokens, downloading it, and then you can drop documents all over. We'll show an example at the end of two guys who used it quite nicely. So moving away from 1,000 directories, I mentioned that it would be nice to have a way to alert if someone is exploring a particularly important database. So in this case, we'll talk about a Microsoft SQL Server. People inside a database that they know nothing about will generally have to map it out first in order to figure out what could be valuable or useful data to go after. And in theory, if we had something in the database that could act as a trap, we could dress it up to be attractive, and we could get an alert. So as we pointed out in the introduction, early passive tokens has quite serious shortcomings. You have to set up all that monitoring. But with Canary tokens, we can simplify it. We can simplify it quite a bit. So the key to simplifying this is just to have it automatically, when that row is read in the table, we automatically trigger a DNS alert that will let us know something's been hit. And how we do that basically here is we just create a table view, and it's a little bit complex, but it triggers the DNS token. But what's cool is that Canary tokens can just generate the script for you. So when you generate the token, you can just simply download the script. The script does the heavy lifting for you. Now when someone queries, say, the user passwords table, which is a table view in this case, by running a command like this, we'll get an alert as usual that someone has been browsing through our SQL server. So we can easily create token table views using Canary tokens using this method. So now I'll talk about quite a different topic. So phishing campaigns, I'm sure we all know, can be a little bit of a menace, and it could be handy to get some sort of alert when they kick off. And one place we can token is an early step in creating a phishing campaign where the login web page of some sort is cloned. So all it really takes is 3 lines of JavaScript. You can check that the domain the page is running on you can check if the domain the page is running on is the one it usually runs on. If it isn't, trigger an alert. What's cool about this is some people have told us you can even get an alert before the phishing site goes live if the people running the phishing campaign run it locally on their machine first. But really, that's just a nice quick token that can be put when a cloned web page goes live. So this is a technique, is a good example of where it can be quite difficult to do with many login setups, but with a token, you can quite easily flag on that.
Let's now look at source code, specifically source code repos. So most organizations have them, and they contain code from current and old or closed projects. Now, usually access to the repos are limited, but sometimes the access is not governed properly, or someone gets credentials they shouldn't have and is able to pull the repo. Being alerted on this pull would be useful in being able to quickly act and stop any leak of the code. So let's look at Subversion, a popular versioning system. Subversion has its idea of external definitions, which are simply local directories mapped to external URLs. This lets you include remote directories in your local SVNs. Using this idea, we simply replace the external's URL with a tokened URL. So when the repo is pulled, the token is hit, and you'll get an alert. Let's quickly demonstrate this to you. So beforehand, we've set up our own repo and added this SVN external. Now, Az, who's a contractor, comes upon this machine, sees it's connected to the network, and sees there's this SVN share for Project X. Sees that there's a phone prototype SVN repo, and decides he's going to pull it to his local machine to see exactly what it's all about. So he pulls it, it all looks okay. There's a single error at the end involving something about an externals. Whether he thinks something's wrong now doesn't matter. Our token's been tripped, and we know something's wrong. In the background, as we've said before, our server gets hit, and an alert is generated, as we can see here. So let's just show you exactly what he did there. So if Az now goes to the repo and shows you the properties of the SVN repo, we'll see that there's a property there for our externals definition. It's just a URL to an SVN location. As we can see over there, that URL is just an SVN token. So now if you go to our Canary token site, provide your details, give a description, and generate a token, there's now an SVN token section where if you open it, there's a simple SVN command where you can use sysadmin or some similar tool and create this externals definition for your repo. You then commit it. Anyone who then pulls the repo will trigger the alert. So this is now useful on either closed projects or fake repos that people shouldn't be touching. And as soon as someone pulls it, you get an alert and know that either your settings on your permissions aren't set up correctly, or someone's just browsing where they shouldn't be. Now, many of you may be using Git instead and want a similar solution. There is and there isn't, at least from what we found. So Git uses submodules, which are similar to externals, but they aren't pulled automatically. So you can add a submodule, and if anyone ever runs Git submodule updates, you'll get the alert. Let's now relook at our simple web bug. We showed that it's a simple URL that when hit, it'll trigger an alert. So typically, web bugs serve a one-by-one GIF, and so does ours. This has its uses. For example, you can put it on a page and no one will ever notice. However, why not let us serve an image? So our scenario is as follows. We want to place an image on a page that actually gets rendered to the person viewing it. At the same time, when this image gets rendered, we want to be able to trigger an alert. Canary Tokens offers you the ability to upload this image and replace the one-by-one GIF with it. So when your token URL gets hit, the image is returned as well as an alert. So we can take a quick look at this process. We're going to be uploading a logo, which we'll use later. So you, as traditional, go to the site, insert your details, give a good description so you know exactly what it's for, and generate your token. There's now a section for remote image where you can upload an image that you select. So once you've uploaded it, you're given a URL that if a browser ever requests an image from it, this image will now be returned. So what have we done here, and how's it going to help us? We've taken a simple web bug and added an image to it. When it gets hit, the image is returned, we get an alert. So what we've basically done is tokening remote images. Our next demonstration will help you see how we can actually use this in a better situation. Device admin pages. We've all come across them on many occasions. Often people have device admin pages that are rarely accessed, and it'll be great to know if or when they ever do get hit. A good example is an ADSL router or a Wi-Fi extender. Now we want to know if someone unexpected logs into our router. The issue we have is that traditional logging has difficulty in integrating here. What we do have, though, is a config page that is simply an HTML web page. All we need to do is replace the logo with a tokened image. Now, whenever someone browses to it, we'll get an alert. So in our previous demonstration, we demonstrated our tokened image. Now we're saying we want to replace the logo with a tokened image. It's a perfect example of being able to create new tokens from existing ones. The basic idea is that you download a copy of the firmware from the vendor site, unpack the firmware using a tool, modify the page by replacing the logo with your tokened image, and rebuild the firmware. Upload it, and restart the router. So now when someone navigates to the page, the token is triggered, and you know someone's there that shouldn't be, allowing you to receive alerts. And So let's summarize this. We noticed there was no easy way for us to determine if someone was accessing our router or device's config page. So we used the previous technique of tokening an image and used that to replace the device logo on the config page. So whenever the page is loaded, we get an alert. You'll also get alerts when legitimate users browse to the page, but using this will be most effective on devices where the admin pages see little or no traffic. So we showed you an example of an embedded device, but there are tons of different places where this could be used. Sysadmins use a bunch of tools and servers on an everyday basis, and they all come with their own admin pages. Tokening any off-limits admin page helps add to your chances of catching an intruder moving around your network. So let's now take a look at the cloud. It's a not so new technology that everyone is using nowadays. What is newish is cloud-based attacks and defenses. Last year, lots of questions were raised and opinions voiced of a controversy involving Facebook's bug bounty program. Wesley Weinberg pushed the bounty's rules and managed to gain access to essentially everything you have on Instagram, including your photos and your messages. When he wanted to publicize the findings and claim his $1 million bug reward, Facebook cited violations to the rules and drama ensued. Disregarding politics, there was a huge security flaw exposed in AWS, specifically around S3 buckets. Now, Facebook is a big company. They're exceptionally smart, they have a large security team, and have smart people working in the security team. Yet there was an attacker browsing the S3 buckets without them knowing. If the buckets could be tokened, there wouldn't have been any sensitive data leak. Essentially, we're looking at tokening files and folders for the cloud. But how do we do this? So to make this happen, we're going to build a Rube Goldberg machine. For those of you who haven't witnessed the fascinating simplicity of their complex designs, I'd suggest you Google it and just enjoy. Basically, a Rube Goldberg machine takes a simple task and deliberately performs it in a complex way using chain reactions. Now, you don't need to worry, our tokening isn't that complicated. We focus more on the chain reaction side. From your side, it's easy. We provide you a script, you provide a couple inputs, and the rest is taken care of. So back to our S3. Let's say we have our secret bucket that no one should be touching, and we want to log any access to it. Our idea then is to monitor access, and when it gets access, we want to get notified. So in order to make this happen, we're going to create a second bucket called login bucket. Whenever we then enable logging on our secret bucket, and whenever anyone accesses it, logs will be sent to our login bucket. We then monitor login bucket for any changes. If there are changes, we know someone is snooping around our secret bucket. So we must mention here that AWS architecture dictates that logs arrive on a best effort basis, meaning they could take a few minutes, they could take an hour or a bit more. However, a couple of hours is still a lot better than weeks or months later via some public announcement. So as soon as there is a change in login bucket, an event is triggered which fires off an AWS process called Lambda. If you haven't seen AWS Lambda, you should take a look. It's pretty cool. It lets you run Java, JS, or Python code in the cloud whenever events happen. So the Lambda function passes a log entry and sends a request to Canary tokens. This in turn will send you an alert. You may be saying that you could use Amazon Simple Notification Service here if you wanted to, and you definitely could, but it means you have to set it all up yourself and manage it yourself. Once again, ISV token takes care of all that for you, as well as condensing multiple logs into a single event, meaning you don't get flooded with events. So let's now walk through a quick demonstration of tripping an S3 token. So it starts with someone getting access to credentials and logging into AWS. Once logged in, the attacker will begin going through your accounts. S3 is usually a good place to start, as there's lots of data stored there and it's quickly accessible. So you see a list of the buckets. Particularly secret bucket looks interesting, so we want to see what's inside of it. Straight away, you see there's an image and folders and possibly more folders and whatever else you want to put in there. But it's important to note now that at this point, the access to the bucket is already logged. Anything that the attacker does from now will also be logged, so you'll see exactly what he does. But even if he leaves now, you know someone's already accessed your bucket, even if they haven't touched anything inside of it. So AWS now will provide the logs, which will get created in our login bucket. This may take up to an hour, as we say, but once they come, our function will run, and you'll get an alert saying someone's snooping around your S3 buckets. From this alert, you can go into your buckets and further examine exactly what happened, looking at your logs. Either way, you know credentials have been compromised. Credentials have been compromised, or you just have a nosy employee sneaking around. As we mentioned earlier, tokens aren't a replacement for logging. AWS CloudTrail is a service that logs AWS API calls for your accounts, and we can't emphasize enough the importance in maintaining and monitoring your AWS logs, as well as using tokens. In fact, Daniel Greslak recently wrote a few blogs about owning an AWS account, and the first thing he mentions is how he goes about disabling logging, as it's a dead giveaway if you do not. So coming back to the Instagram hack, they had someone snooping around their account and viewing sensitive data on S3 buckets without ever knowing. If they were alerted on their access, they could have stopped the attacker moving around. IS3 token alerts you on access to a bucket. You put this in a fake bucket or a bucket that no one should be accessing, and any alerts will be important alerts. So we've talked a lot about software, tokens, and how to determine if someone is moving around your network. But what happens when someone is physically in a location they shouldn't be? What happens if you have a physical breach? As an example, your CEO is crossing the border and his phone is seized. Or alternatively, you have an off-limits data center. How can you determine if someone is inside? QR codes are our stab at tokening physical locations. So what you'll do, you'll put a QR code on the back of your battery. If someone seizes the phone at a border and dismantles it, and they see the code, we may get notified. Or you put it on the wall of your data center, or for any sort of asset tracking. If someone scans it, they'll hit our token, we'll get an alert and know that someone's somewhere they shouldn't be. So let's quickly demonstrate this to you. So in my wallet here, I've put a QR code, and I've left my wallet lying around by mistake, and I've walked away. Az comes along, sees it, and starts rummaging through. He doesn't see much. What he does notice, though, is that there's a QR code. Now, who puts a QR code in their wallet? So it's going to be pretty interesting, I'm pretty sure. So what he does, I can show you. takes out his phone with his QR scanner, scans the code. As all QR codes do, it navigates into a site where he sees this little quote and web page. Without him knowing, though, in the background, this has hit our server. This has also created an alert, which we'll be getting soon, which will notify us that someone's rummaging around a wallet, as an example. So, as we can see here, alerts come through saying our wallet QR code has been hit. So that was just an example using your wallet. As we said, you can put it in data centers, you can put it in places people shouldn't be. And if it ever gets scanned, you know. The important thing is we're looking for people who are unfamiliar with the territory and they're exploring it. Someone who knows about it won't be scanning it. Someone who doesn't know about it will see it and be interested, possibly scan it, see if it contains any information.
So if instead of, say, looking at the back of the phone with the battery trying to detect someone who doesn't know, who shouldn't be there snooping around, if we turn around the phone and look at the front and take a look at the apps, there's plenty of sensitive things to be had, like email or 2FA. And if a phone is left lying around, unlocked, or the owner forced to unlock it, someone could have a chance to go through the apps and start opening stuff and looking for whatever they can find. So if, for example, this is a C-level exec's phone or a sysadmin's phone, it could be useful for others to know that someone is rifling through the apps and perhaps trying to get at emails or 2FA details. So one of our colleagues, Jason, built a proof of concept iOS app called Secret Keeper, and it reports to store all manner of secrets, but in actual fact, it's just a tokened app that will send us alerts whenever opened. So with this app, the work is essentially done and already hooked up to our alerting, and it only takes a few minutes to install and configure. So it's not in the App Store, but you can get the source of the app, modify it if you need to, and install it quite easily. So let's take a look at that. On my phone here, I have Secret Keeper already installed, and quite foolishly, I've left it lying around. So Nick happens to be in the vicinity, and he picks it up. And he starts taking a look through the apps, checks out notes, for example, sees that perhaps I've left a work email password, but not satisfied. He's going through the rest of the stuff, and he noticed the Secret Keeper app, so starts to try look at it. So now he sees that there's a passcode entry. He'll try to enter some passcodes, but it doesn't really matter, because as you can see in the background, we've already gotten an alert that the Secret Keeper app has been browsed, and so we will have known that someone has been in my phone and going through. As an added advantage, the app also sends through a photo of the person looking at it and the location. So that could be helpful just in case you are after some sort of male model or something, and at least now you know what it looks like. So to recap what we just saw there, by leaving that app lying around, you can get an alert when someone's snooping around and opening apps.
So we've spoken a lot about applied tokens and how we can use them in different settings. Now we want to show you how we're improving the information you can get out of the tokens, or using tokens to get more information out of somewhere. In an attempt to help better understand the threats, we've included a few techniques that try to de-anonymize the attacker. If they work, we show you the extra information, but they won't always work, simply because possibly the attacker just disables access to it. When they do work, though, we can learn a little bit more about the incident, which can help narrow down where it originated from. So we've extended our web bug to include details about the host browser. What this means is that you're able to grab some more details about who is tripping a token. This is achieved using plugin detect, which is an available JavaScript library. The JavaScript enumerates plugins and sends the details back to us. The extra information then helps us to get a sense of who's triggering the alert and supplies audit information if you want to do forensics. So here we can see additional information about the incident. We can see Flash and JavaScript are enabled, as well as some browser-specific information. WebRTC is an open framework for real-time web peer-to-peer communication. So using a trick exposed by Daniel Rossler, we can use WebRTC APIs to expose local and public IPs, even if you're behind a VPN or proxy, by making Java requests to a stun server. These stun servers are used between peers, between nets, to share public IPs so they can directly communicate. So on a Windows machine using Chrome or Firefox, if WebRTC is enabled, when we load our webbug page, we make the calls and attempt to get the IPs. This won't always work, but if it does, it provides us with some useful information. As we can see here, where our public IP was exposed as 190.x, but provider assigned IP was actually 169.1, and even our local IP, our local network IP was there. So in the past, we've seen other attempts at obtaining a user's local and public IPs. These have included using Flash and JavaScript to get information. WebRTC is just the current flavor and has already been begun to shut down. When the next trick comes along, we'll add that to our scanner. It's all about getting every bit of information about the threat so we can understand it and act upon it. Another quick check we can perform is to let us know if the attacker is routing through Tor. It's easily done. We can check if the source IP is in the list of known public Tor exit nodes. As can be seen here, this request has been identified as a public Tor exit node. Previously, our token hits were isolated, meaning we didn't have any easy way to compare previous hits on tokens. We've now added history to tokens, enabling you to view a list of the previous hits. Now, why would that be useful? Let's say you normally get admin config page hits from somewhere expected, your office, for example. All of a sudden, you get a hit that comes from some external place. In the past, it would be difficult to see the relationship between these hits. Now you can quickly see that this is an outlier and needs immediate attention. As you can see, we've also included a map, which just lets you get a quick sense of the attacks at a glance. But importantly, you can see a list of the events and more information about them, possibly giving you a better chance to deal with them. Our whole idea here is to give you more information. The more information you have, the better chance there is of resolution to the problem.
So to round off this section on getting more information, so another way in which we can use tokens to get a bit more information is with honeypot. So clearly the early honeypot researchers and sysadmin did this, and we also thought we'd try a hand at this. So we integrated tokens with a commercial honeypot that we run, and it's a way it's possible to customize the files in the honeypot's file share. It's easy to simply embed token files alongside those honeypot files. And we mention this because while we were doing this, two people were doing something very similar using canary tokens as well. So Claudio Granieri and Colin Anderson were investigating attacks using malware on human rights activist computers. And for those that recognize Claudio as the creator of the Cuckoo sandbox for malware analysis, the next part won't be so surprising. So they set up a honeypot, used canary tokens to generate taken docs, left those docs on it, installed some malware on the machine. And when the attackers got onto the machine, they pulled the docs and took them away with them. And this got them a little bit more information about the attackers. So they hit from a number of different IPs, mostly VPN endpoints, but a few of us it weren't, and they believe that this IP on the screen is an actual IP that was used by one of the attackers. This is the sort of situation where the token uncloak that Nick talked about could possibly help a bit in the future. Even if it doesn't help in every case, there will be some cases where it could be useful to get a bit more information. It was surprising to us at least that, like the person who asked the question about someone being able to pick up that it's the canary tokens DNS. So we thought the same thing. These guys used our canary tokens DNS server, and we were quite surprised with that. We assumed they'd use their own custom domain to be a little bit more discreet, but it worked for them. And everyone else, it can work for other people as well. Everyone's welcome to use the public hosted instance we host, and we really enjoy getting feedback on how it's used. As we mentioned before, canary tokens is open source, so you can use it as CFIT, and there's some Docker images. So to bring this talk to an end and wrap up what we've been talking about, so we've been talking about a revival of the idea of the sort of tokens with the Canary Tokens project, and what we really aim to do is ease the creation of tokens so that it's easy for the rest of us to experiment and make tokens that look valuable and deployed in places where attackers are likely to snoop around. So like those two malware researchers, if there's a chance where it could be useful, there's no need to build any infrastructure. You can pick it up immediately from our hosted instance, and you'll easily get started. So go ahead, use tokens to attempt to cut down on those lengthy breach detection times and token all those things. Thanks for listening, guys.